When two parallel light rays, they were lost in the space and they were fighting to reach their destination. But when they became parallel to the principal axis, eventually they reached the reflecting surface of the concave mirror. Then they directed towards their destination, and that place is very much beautiful. And that point where these two parallel light rays converge or meet, and that point is principal focus. Welcome back to the class, all of you. This is class 10 physics, and we are very much busy with light chapter, right? Today, we'll be continuing with a few more beautiful concepts of this chapter, right? Shall we start? Yes, of course. We have to start, right? Chalo, we'll do that. Previous class, we have studied about principal focus in case of concave mirror as well as in case of convex mirror. Today, we are going to understand about a formula which is going to create in this situation. What is that formula and how it is going to create? Now we'll see that, right? Come. See, concave mirror, how the concave mirror is going to look like, right? It's very interesting. See, this is curved inward. See here, curved inward, and it is all about coating, right? Coating. See, entering the cave. See here, entering the cave is nothing but what? Concave mirror. I'm going to draw a few things very much necessary, right? All of you. Important terms. Important terms. What is this thing, all of you? This is pole, right? This is center. In between this center of curvature and pole, what we are going to have, most of the students, you get confused in this situation. You should not get confused, right? Exactly the midpoint of this CP line segment is what? This is principal focus. That's what we're talking about, right? Principal focus. And now, and we all know that this is principal axis. When it comes to the parallel light rays, when you hear this word parallel light rays, it's always about they are coming from infinity. Correct? All of you getting? When some light rays are coming from the infinity, then it is very much sure that these light rays are parallel. I'm going to bring such parallel light rays now. See here. This is one parallel light ray, right? One more light ray, approximately parallel, because I'm drawing on the board. I'm not having any instruments here. Try to understand, these diagrams are rough diagrams, okay? And within few days, I'm going to show you how we can draw all these things geometrically, exactly, accurately, right? Now, what is going to happen here? As I said during the introduction, these two light rays, they were lost in the space. Now both they have become parallel to this principal axis. When they reach this reflecting surface, this reflecting surface is like a guru, right? What guru is going to do in our life? They are going to show the right path, a right place, where we can get the knowledge, where we can get the clear understanding about the life, right? So now, after reflection, this light ray will be going like this, right? Exactly through this point. You can make it correct, right? I'm sorry. Okay. This light ray will be going in this way, right? After this light ray, again through the same point. This point is what, all of you? This point is principal focus. This is what we have discussed in the previous class. But what I am going to tell now, why I am drawing this diagram one more time, there is a reason. What is that reason? See, listen here. Distance between C and P. What is that, all of you? Remember the basic definition, what we have learned. What is that basic definition? Distance between C and this P is radius of curvature, right, all of you? What is this? Radius of curvature. And one more thing we are going to learn now, that's very much simple and very much important. Distance between F and P. Distance between F and this P is small f. Don't get confused in the diagram, very much simple. I'm telling you, distance, this point is what? Principal focus, capital F, and this is pole. Distance between F and P is a small f, and small f is nothing but focal length. What is this? Focal length. Where I'm going to write, F is nothing but focal length. Okay, done. But what is that formula I'm talking about? What is that formula? That formula is about relationship between radius of curvature and focal length, right? What is this radius of curvature? See here, radius of curvature. This is f, right? So now focal length. How you can define focal length with the help of radius of curvature? We know that R equal to F plus F. Don't get confused. I'll be explaining completely. Okay. In my class, I'm going to explain deeply. Okay. You should not have any doubts after my class, because this is how I'm thinking about my class, right? All of you. R equal to F plus F. What is R? R means here. R. R means what? CP, right? R means CP. What is F? F means FP. See here. This is FP. FP means F. FP. One more thing, you just listen about very much carefully. If you consider CP equal to 5, if you consider CP equal to 5, this point is exactly the midpoint, then this is 2.5. If it is 2.5 means this is also 2.5. That means FP equal to F means CF equal to also, CF is also equal to F only. That means CF, right? See now, CP equal to FP and FC or CF both. Okay. Finally, we can write R equal to 2F. R equal to F plus F. That means R equal to 2F. That means radius of curvature is nothing but twice the focal length. Is that correct, all of you? Radius of curvature is nothing but twice the focal length. Very simple, right? The same process is going to happen in convex mirror also. How it is going to happen? Let us see now, right? Draw the curve outward. This is curved outward. This bulged out part is the reflecting surface in this convex mirror. Here the reflecting surface is here. This is a reflecting surface, and here this is reflecting surface. This thing is okay. Here inside we are doing coating, and after that, all of you, it's all about drawing the important things, I mean important terms which we studied. This is the principal axis, and obviously this is pole, and this is a center of curvature, and this is principal focus. Okay. It's very much simple that always we must mark the pole first. Okay. After drawing the pole, just take some radius like 5 centimeter, 10 centimeter, depends upon you, but go for 5 centimeter. From P to C, 5 centimeter. Place the tip of the compass exactly on the C and draw this arc. You'll be getting the figure. After getting the arc, okay, you just consider this PC line segment, and find the midpoint, that is F. I'll be showing that how we are going to draw geometrically in one class. In another video, I'm going to do that. So now, what I'm going to bring now, can you guess, all of you? See, whenever you're going to analyze this principal focus, you always need to bring what? Parallel light rays. And I said that very much clearly. When it comes to parallel light rays, it's always about infinity. Those light rays are coming from the infinity. They will become what? Parallel light rays. Now my parallel light rays are coming. This is one light ray and one more light ray is here. These light rays are coming, but how they are coming? By becoming parallel to this principal axis. These two light rays are parallel to this principal axis. Okay, after after hitting the reflecting surface of the convex mirror, what is going to happen? The magic is going to happen. When it comes to spherical mirrors, it's all about magic, right? All of you. But what kind of magic? Here, the magic is created in this way. How the magic has been created here? See, these parallel light rays, they have come, and after hitting the reflecting surface, they converged at a particular point. But here, these parallel light rays are coming, but they are not going to converge. They'll be going to be diverged, right? How they are going to diverge? See here, how they are going to diverge. Parallel light rays, they will be coming and hitting the reflecting surface, then they will be getting diverged, right? This is all about convex mirror. But if you extend these light rays, these diverged light rays backwards, they'll be meeting principal focus here. Same way, same way, correct? Now I am going to give the definition. Principal focus, in previous class also I have told, but I am going to repeat it. Repeating the definition and writing the definition again and again and thinking about in different ways. This is what we call it as a study. Now, this is a point. Principal focus in case of concave mirror is a point where these two parallel light rays converge after reflection. But here, principal focus in convex mirror is nothing but it's little bit different. Please focus upon exactly on the principal focus, right? It is a point behind the mirror, all of you. It is also point only, but behind the mirror, from which light rays appear to come. They are not coming in reality, but appear to come. That's why you know that what happened exactly here. Light rays, they have come and they hit this reflecting surface and they get diverged. Diverged means what? They'll be throwing away. Okay, broadly, largely, you'll be understanding why it is going to happen and what is the exact application. But now you understand this. These parallel light rays, they have come and they hit the reflecting surface. They got diverged in this way, but they are not going to meet. When they are moving in this direction, they are not going to meet. That's why our brain tricks something here. That means these diverged light rays will be tracing back and will be meeting exactly at the F. That's why the definition is like this. What is the definition? One more time, all of you. The point behind the mirror, from which light rays appear to come after reflection. I know we studied all these things in the previous class, but I am just doing all these things just to get the formula. What is the formula? What is this? P and C is what? Radius of curvature, right? What is this thing? Distance between P and this capital F is small f, focal length. If it is focal length, this is also focal length. We studied in the previous case. Then what is this thing? R equal to F plus F. Again same thing, right, all of you? R equal to F plus F, which is equal to 2F. What does it mean? What does it mean? Radius of curvature is equal to what? Radius of curvature is equal to twice the focal length. Twice the focal length. Okay, very simple. If you want to understand it practically, means if you consider PC equal to 5, if you consider PC, that means radius of curvature equal to 5, Then PC equal to what you can write all of you? PF plus FC. PF plus FC. What is PC? PC, I have considered it as 5. That means PF is also 2.5. This is also 2.5. Then 5 equal to 5. This is just for the checking, okay? When you are doing the things in the science logically, it has to be checked logically, okay? This is all about these two concepts, and the formula what we have got is very much important to solve the problems, okay? When it comes to physics, it's always about maths also, so please be aware with your mathematics, your basics, everything, okay? Can we move ahead now? Can we? Yes, of course. The next concept is image formation and characteristics, right? We need to study some points here. These are some statements which helps us to understand the concept. The first thing is at least two light rays must meet so that image forms. So if you want to get the image, at least two light rays must meet, must cross, okay, must converge. You can take that in any way, right? So the thing is that at least two light rays must meet. That is the first thing if you want to create image. Okay, hope everybody has got this right. Second thing, if two light rays actually meet, then they form real image. Here comes the confusion for the most of the students, but I won't allow it to happen, right? The thing is that if two light rays are meeting exactly in reality in front of you only, they are meeting, that means it is happening really, okay? There is no illusion. For example, uh, now I am speaking, now I am teaching to you in front of this camera. This is not an illusion. This is a reality, right? Then you can say this thing related to the second case, okay? When two light rays are going to meet in front of you really, then you will be getting the real image. This real image is image. We can get this image on the screen. The image which you can get it on the screen, that image is called real image. Next, if two light rays appear to meet, then they form virtual image. Appear to meet means what? Appear to meet means they are not meeting in reality, but it feels that it looks that they are meeting. For example, you just stand in front of the plane mirror, but when you see the plane mirror, you see yourself in the mirror, but in reality we're not inside the mirror, but it is an illusion, right? It is an illusion for us that we are there inside the mirror, but in reality we are not in the mirror. That means that image is virtual image. Here light rays are appear to meet, they are not meeting. It feels that they are meeting, but in reality they are not meeting. We'll understand the cases, but you just understand the sentences now. It's more than enough. So these are the 3 points which we must require to go ahead. I hope everybody has understood. Very simple. The first thing is at least two light rays must meet so that image forms. If a light rays they meet in reality or they meet actually, then they form a real image. If they are appear to meet, they are not meeting. If they are appear to meet, means that is virtual image. Okay. So now we'll be going for image formation in concave mirror. Finally, we are here, all of you. We must feel good about ourselves. Now we'll go for image formation in concave mirror. Before that, we must study some rules to create image for concave mirror, right? Let us study rules now. Finally, we have come here, all of you. It's a right moment for us to enter the chapter in deep way. So now, image formation in concave mirror. So before creating the image, we must study the rules. As I have said, the first rule is here. What is the first rule, all of you? A light ray parallel to principal axis. When a light ray is parallel to the principal axis, what happens after the reflection? See here, I will be taking one light ray, right, which is parallel to the principal axis. See here, I have taken this light ray. As I have said, this light ray is parallel to the principal axis, but after the reflection, this light ray is passing through principal focus. This is the first rule, all of you. Very much easy. When a light ray is parallel to the principal axis, after the reflection, it will be passing through principal focus, as I have shown here, right? This is the first rule. See here, it has come and it has gone in this way through principal focus. Second one, a light ray passing through F, that means principal focus. I am going to consider one light ray which is passing through principal focus. See here, a light ray is passing through principal focus, but after reflection or after hitting this reflecting surface, it will become parallel. It will become parallel to the principal axis. This is principal axis. Very much simple. Second rule, when a light ray is passing through principal focus, after hitting this reflecting surface, it will become parallel to the principal axis. Very much simple. In this way it will go, and in this way it will become parallel to the principal axis. Third one, a light ray passing through C. A light ray passing through C means how it will happen. Consider light ray. See, this will be passing through center of curvature. C means what? Center of curvature. Here is the game. What is the game here? When the light ray passes through C, after hitting this reflecting surface, it will be going back without any deviation or without any change in the direction. Everything will become quite normal. Normal in which way? It will be going and it will be coming back. This is what we have learned in this case, right? It will be going in this way, hitting the reflecting surface and going back in the same path which it came initially, right? This is all about third rule. Fourth rule is what, all of you? A light ray incident on the pole. Where is the pole? This is the pole. Take a light ray and incident on the pole, right? We have taken a light ray and we have allowed to incident on the pole. When the light ray incident on the pole, obviously it is going to reflecting back, right, all of you? It will be reflecting back. But how? By following the laws of reflection. For example, this is 30 degree means this is also 30 degree only, right? The angle of incidence is always equal to angle of reflection. These are the main important four rules which we must know before studying image formation in concave mirror. Can we revise now, all of you? Can we revise? Yes, obviously. Okay. First one, a light ray is parallel to the principal axis. After reflection, it will be passing through principal focus. It will be going like this. It will be passing through principal focus. Second one, when a light ray is passing through principal focus, after hitting this reflecting surface, it will become parallel to the principal axis. Third one, a light ray passing through C. It's a special case. Nothing is going to happen here. Everything is quite normal. It will be going through C and again going back through C. Fourth one, a light ray incident on the pole. When you are going to incident a light ray on the pole, it will be reflecting back by following the laws of reflection. The laws of reflections are nothing but angle of incidence equal to angle of reflection. So now we have finished rules. In the next class, we are going to create image in case of concave mirrors, right? Till then, work hard, study more, and you have to be special means you have to do special stuffs in your life. Okay, all the best. We'll meet again with the next concept in the next class. Till then, goodbye.